Hi, and welcome to Scaling Applications on Oracle Cloud Infrastructure. My name is Larry Beausoleil, and OCI Enablement Product Manager. A quick safe harbor statement to go ahead and take a second to review this. So what we're going to be talking about today is describing scaling options, identify horizontal and vertical scaling scenarios, describe compute, storage, database, vertical scale, and then describe auto scaling and the metrics involved with that. The first piece we want to take a look at is scaling primers, and this comes down to vertical scaling and horizontal scaling. The key differences here, it's kind of dependent on the application. It's dependent on if you're using database or an application that can actually scale horizontally. Some of the increases for scaling vertically will be CPU, RAM, storage, and those are something that you would still use potentially in a horizontal scaling idea after you've gathered enough metrics. Maybe you increase the actual instance size that you're using going forward to help you reduce some of the workload. Some of the pros to this, for a monolithic architecture. So if you're bringing like doing a lift and shift application into OCI, you may be just increasing the instance size to handle the workload. The downside is you will have to stop the instance and increase it unless you have a custom image to where you can have that old one launch from a custom image and then increase, basically do a DNS cutover to the new instance or move an IP address to the new instance. So that's another idea. Horizontal scaling is going to be a little bit better. And the reason for this is you can have a pool of resources, and so you can scale over time. You can increase or decrease your workload at a much higher rate. This may require restructuring the code because you're going to have to work with a little bit more stateless code as opposed to stateful application code. But it's something that is a key benefit to using the cloud. So vertical scaling, so you're going to take the instance offline, and then you can scale inside of the family of that instance. So if you have a VM standard 2.1, then you can increase its size there. Now, if you want to change that, you would have to create a custom image, or you would have to do, there's a couple other pieces that would have to be implemented to actually increase or change for vertical scaling. At the time when you do this, you can also increase your storage size. You can add more volumes to this particular instance to increase size, and then you can also change, as you can kind of see in the next one here, the block volume. You can actually resize and expand that. So this can be done, so you can start at a 50 gig and then over time increase, because you don't want to start too high. You want to have an alert if you're getting close to 80% usage, and then you're going to actually increase that over time, as opposed to starting out with a 32 terabyte block or boot volume. It's better to start small and then increase, but this also comes down to what volume size or performance you actually need. So if you need a high amount of performance, you might have a larger volume to start with to get a certain set of IOPS. So vertically scaling for a boot volume for Linux partition resize is going to look like this in this particular steps. So you're going to have to stop the instance, detach the boot volume, attach it to a second block volume, run parted to edit the partition, and then you're going to have to run a couple commands inside of the actual OS, and then attach it again and restart the instance. For the boot volume for Linux partition resize, once you actually have this, this is going to be a manual partition resize, or you can do an online automatic partition resize using cloud init scripts. So you can, as you can see here, it's sudo yum-y install cloud utils grow part, and then goes through the entire process, and then you'll just have to run a couple commands when you actually log into it. If you're going to be doing this with Windows, it's going to take a little bit longer because you're going to have to actually open the disk management, and you want to make sure that you're using Server 2008 unless you want to play around with registries, and you still have to consider the disk signature collision errors that you can run into if you're using a newer version of Windows. So you can do it, but it just takes a little bit extra time if you're not using Server 2008. You can extend the volume, and then you can use the command line, open command prompt, and then run disk part and select extend the volume. This can also be done from the GUI, so it's just a matter of what you prefer in that case. So vertically scaling database systems, you have virtual machines, which you can scale storage up with no downtime. You have bare metal, where you can scale your CPUs and scale down with no downtime. And then Exadata, you're going to be able to scale CPU scale up and scale down. You can also change your rack shape from a quarter rack to half rack to full rack. So this all of this stuff you would start, especially if you're doing a proof of concept, you're going to start smaller and expand unless you're already running this on-prem and you're doing a migration. So maybe you're using something very similar and you're like, I know exactly what I need. So go ahead and start with that inside of OCI and then adjust from there. It's much easier to scale up in a lot of cases than to decrease the resource size, especially when it comes to storage. To kind of help with this scaling option, we have instance configurations and pools. So you're going to create from a running instance, you can create a config file. In some of our other modules, we kind of dive into this and talk about this a little bit more. I'm just going to cover this from the scaling perspective. And then we have the instance configurations that you can run multiple instances, and you'll set this up in different availability domains, and then you can also control all of these together, attaching them to a load balancer. Once you have your instance configuration and your instance pool set up, this is going to kind of build, these are some building blocks that we'll need to actually link to auto scaling so that we can grow and shrink the size of the pool, because we've gone from a vertical scaling option, and this is getting into our horizontal scaling option. So horizontal scaling, we're going to do this based off CPU or memory. And this is something that will start with a minimum size, maybe one instance or two. We have an initial size, and then we have a maximum size. And all of these key components here are dependent on what your application's running at. So your minimum size should be something that your application can still function. Your initial size should be, it's working great. And then your maximum size is what do you want it to scale to? Now that one needs to be, you need to do some testing based on your performance metrics, based on maybe how much traffic is getting sent towards your instances, and then scale accordingly for that, and have that maximum set. So do you want it to scale to 1,000 instances, or do you want it to scale to 100 or scale to 80, or where do you want it to stop? And you also have to consider the soft limits in the account for the actual instances as kind of your maximum size as well. So auto scaling configuration rules. So you'll set your CPU utilization and memory. You'll have your cooldown, and so the cooldown is to stabilize before it starts scaling again, and this is going to be the minimum value is 300. You can also change this and increase this because maybe the application takes a little bit longer to configure, and that would be a reason to maybe increase it. But do some testing and see how long it takes for your application to get set up. And this kind of goes back to the custom image, managing custom image talk that we have in another module, where do I have a golden image or do I have an instance that's going to install on boot up? The next piece here is the metrics. So we will scale based CPU or memory utilization depending on the application requirements. And then scaling rules will have a scale out operator, so greater than, what's our threshold percentage, and less than. And then we'll add a number of instances to our pool based on those requirements. Now, our threshold percentage, you might want to increase this or decrease this. Depending on how long it takes for your instance to get up and running will dictate what the threshold is that you want to meet. But then you also have to consider your cooldown. So if I scale out a new instance and then I have a cooldown of 300 before I start even looking at my metrics again, I may not be scaling fast enough, so I need to add more instances than maybe thought at first. So do some testing, play around with it. And then once you have this configured, you can attach this to a load balancer. And so you'll have your load balancer as your front end with your initial, and then as instances start expanding or as you start adding, then those will attach behind the load balancer. It can start sending traffic to those. And then on scale in, terminate nodes are automatically removed from the load balancer, so it'll stop sending traffic to those particular instances. Uh, and then if you use autonomous database scaling option, and there's some other modules that dive into this a little bit more, this kind of takes care of all the configurations for you. You won't have to worry about scaling up or scaling down. It's going to handle that. You just kind of send traffic to it, and it'll take care of it. So thank you for your time on understanding and learning scaling on OCI. Have a great rest of your day.